Okay, we're going to talk about measure of spread. The measure of spread we're going to talk about is primarily interquartile range, or IQR. There is another type of measure of spread called standard deviation. And as far as their behavior, there are a lot of similarities between the two of them, but standard deviation is interquartile range is more resistant to change. It doesn't move as much because of the way it's calculated. It doesn't change when you add new values as much as standard deviation does. And so anyway, we're going to go straight into this, and what I want you to understand is how measure of spread relates to the median, or if you're talking about standard deviation, the mean. Okay, so the mean is you use standard deviation. And the mean and the median, one of the uses of the mean and the median is that they kind of approximate or give you an idea of what a typical value is. So they describe, when we're describing the data, they represent what you would expect to see as a normal value. So we're going to look at this data. We're going to make box plots for each of them. We're going to compare them, and let's go ahead and get started with that now. So if we look at this first data set A, the minimum is 1, the maximum is 19, and then we find the median by finding the middle value. There are 9 values here, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's also 9 in the bottom set as well. So if we're going to divide that equally into 2 groups, 9 doesn't divide equally, so we're going to have 1, 2, 3, 4, 1, 2, 3, 4, with one in the middle. That one in the middle, or middle value, is our median. So our median in that case is 11. Now once we've divided it, we're not going to use the median in calculating the quartiles. We never are. So we've got 2 different groups, lower half, upper half. We're going to do the exact same thing. We're going to find the middle of this group. Now there's 4 different groups and 4 different numbers. And so when you divide 4 into 2 equal groups, you get 2 in each one. Now, halfway between these 2 values, that's going to be our quartile. So if we take 2 plus 6 and add it together, we get 8. 8 divided by 2 gives you 4. So our first quartile is going to be 4. 4 is halfway between 2 and 6. And we do the same thing up here. 2 and 2, halfway between 15 and 17 is 16. And we can calculate our interquartile range now. Q3 minus Q1 is our interquartile range. So 16 minus 4 gives you 12. Now we're going to do the same thing for B. And our minimum is 3. Our maximum is 15. And then our middle value, we've got 4. 1, 2, 3, 4 here. 1, 2, 3, 4 here. Again, remember there's 9 values, so 9, you can do however you want. You can just count from each side until you get to the shared spot in the middle, or you can 9 divided by 2, 4, and 1 left over. That's it right there. Okay, so 10 is our median. Then we divide this group into 2 equal groups. Halfway between 6 and 8 is 7. That's our first quartile. Halfway between 12 and 14 is 13. So for this one, we subtract 13 minus 7, which gives you 6. And you can see that our interquartile range is quite a bit smaller here, 6 compared to 12. So now we're going to go ahead and graph those. And so the first one we're going to graph is A, and it goes to from 1 all the way to 19. Okay, first quartile is at 4. Median is at 11. And third quartile is at 16. And I can connect those and make my box and whisker plot. So that's Q1, median, Q3. A maximum here and minimum here. Okay? B is going to go from 3 until 15. 1, 2, 3. 15 is over here. And what do we have? First quartile 7, 6, 7. Median 10. And third quartile 13. 11, 12, 13. Now you should see they obviously look different. This graph is much longer, more stretched out than this one. I don't know what you're thinking, but when I look at this, I tend to think, that maybe this is a bigger graph, and so maybe it has more numbers in it. Make sure you understand that's not true. This represents the same number of numbers as this one. So the size of the graph, the length of the graph, doesn't necessarily tell you anything about how many data points or how many numbers are involved. So to illustrate that, I'm going to, for each one of these points, I'm going to put a point along the line. So 1, we need a point there. 2, 6, 7, 8, 11 right there, 12, 13, 14, 15, 16, there's no number there, so 17, and then 19. So all of these larger dots, so even though this is our quartile, there wasn't actually a number up here that's 16. It's just our dividing line. So we got numbers here, 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 not here, and here. Okay, so they're spread out kind of evenly. Now, on this one, we got 3, 6, 7. There's not actually a number here, because remember up here, there's not a number here. There's no 7. That's just our boundary. And there's 8, 9, 10, 11, 12, 14, 15. Okay, so as you can see, these are spaced out much more, right? So that's what we're talking about literally when we talk about a measure of spread. These are spread out, these are not. And so what does that mean? Well, that one thing that means is that if we say that the median here is 11, we don't have as much of a chance of having a number that's close by 11 as we do here for 10. So if I say that, most of these numbers are pretty close to 11, you can look at that and say, well, it doesn't really make much sense. And that's 11, but we got to go. Look how far we have to go to get to the next numbers. There's nothing really close by. Down here, if we say that 10 is a normal number, you say, yeah, okay, that makes sense. We've got 4 other numbers that are all within 2, right? That's 10, there's 11, there's 9. Those are really close. And then 12, and 8. So those are all real close, much closer than up here. So that's one of the main things about measured spread. Now, the other thing that you need to know is how adding numbers in will tend to change it. So if I put a number out, an extra number out here, for instance, it's going to tend to pull all of these lines this way, all of the quartiles. Now, if I put one here and here, this one will get pulled here, this one will get pulled this way, and this one will get pulled by both of them. So whichever one, so it may not move very much. So let me show you what that looks like. Let's say I add a number on this side, 1, we have 1, 3, 6, 8, 9, 10, 11, 12, 14, 15, and 17. Okay? So now, when we look at these, some of these numbers are not going to change very much. Okay, the minimum got smaller. It's now 1. We'll get to Q1 in a second. Now the median didn't actually change because I put one number on this side, one number on that side. Remember I said it's pulling in both directions. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be 1, 2, 3, 4, 5 here, 5 here, with 10 still in the middle. So 10 is still going to be our median. It got pulled both directions and stayed in the middle as a result. And then Q3, the maximum is now 17. And now we look at the middle numbers here. So we want to go 14 will be Q3. And we go 6 will be here. Now notice before, for B, this is from B, it was at 7, now moved to 6. It was at, what was it before, 13, now it's 14. So that's what's happening to this. It's getting more spread out. So we've got our minimum is at 1. Our maximum is at 17. And 14, and as you can see, it pulled it out and stretched it out a little bit more. So when you have a number, when you put a number on the outside of your data set, it's going to expand and spread out those numbers. And that's true for the interquartile range. It's also true for the standard deviation. So for our purposes, what we've talked about so far, everything that's going to be true here will be true with the standard deviation. It just won't be, it won't move it quite as much, or here it'll actually move it more. Okay?